Alright, let's dive straight into the fascinating world of plasma propulsion systems used in space. Now you may be thinking, plasma? What? But trust me, it's not as complicated as it sounds. Plasma is often referred to as the fourth state of matter, following solid, liquid, and gas. When a gas is energized, its atoms become ionized,
resulting in a sea of charged particles known as plasma.
Now, this is where it gets interesting for us space enthusiasts. In a plasma propulsion system, this ionized gas, or plasma, is expelled out of the spacecraft to create thrust. It's kind of like how a balloon filled with air will zip around the room if you let the air out. But instead of air, we're using plasma, and instead of a balloon, we're propelling a spacecraft through the vacuum of space. To ionize the gas, we use something called an electric propulsion system. This system applies a voltage difference between 2 points, creating an electric field. This electric field accelerates the ions in the plasma to extremely high speeds, and then they're expelled from the spacecraft. They produce a force that propels the spacecraft forward. This is a fundamental principle of physics known as Newton's third law. For every action, there's an equal and opposite reaction. In this case, the action is the expulsion of the plasma, and the reaction is the movement of the spacecraft in the opposite direction. Remember, this is all happening in space where there's no air resistance or friction to slow down the spacecraft. So even a small amount of force can accelerate a spacecraft to incredibly high speeds over time. Now, isn't that a fascinating piece of science? But that, my friends, is just the tip of the iceberg. There's a lot more to discuss about these remarkable engines, including the different types of plasma propulsion systems and their applications in space missions. So stick around, because things are about to get even more exciting. All right, now that we've got a grasp on the basic principles of plasma propulsion, let's dive into the different types of these systems and their specific applications in space missions. First up, we have the Hall effect thruster. Now, these bad boys use a magnetic field to trap electrons, which then ionize the propellant and produce thrust. The interesting thing about Hall effect thrusters is that they can operate at higher efficiencies and for longer periods of time than some other types. They've been used in various satellite missions, and they're considered quite reliable. Next, we have ion thrusters. These work by firing a stream of ions, positively charged atoms, out the back of the spacecraft. NASA's Dawn mission, which visited the asteroid Vesta and the dwarf planet Ceres, used an ion thruster. They're incredibly efficient, but they also produce a very low amount of thrust. So they're best suited for missions where speed isn't a crucial factor. Then there's the pulse plasma thruster. These work by using a small amount of propellant, often a solid material like Teflon, which is vaporized into plasma. An electric current is then sent through this plasma, creating a magnetic field which accelerates the plasma out of the thruster, creating thrust. These are great for small adjustments in a spacecraft's position or orientation. Finally, we've got the Vasimer engine, or the Variable Specific Impulse Magnetoplasma rocket. Now, this is a bit of a mouthful, but it's a pretty cool piece of technology.
The Vasimer engine can adjust the amount of thrust it produces, allowing for greater flexibility in its operation.
It's not yet been used in any space missions, but it's highly anticipated for future long-duration missions, such as trips to Mars. So, as you can see, each type of plasma propulsion system has its own strengths and weaknesses, and is better suited to certain types of missions. It's all about using the right tool for the job. I would love to, but what about using these systems here on Earth? Well, that's a whole different challenge, and that's what we'll delve into next. So, stay tuned. Let's shift gears now and talk about plasma propulsion for terrestrial usage. It's a tantalizing idea, isn't it? Imagine aircrafts zipping around our skies, powered by the same technology that propels spacecrafts through the cosmos. But, as you can probably guess, it's not that straightforward. The first major challenge is the air resistance. You see, in space, there's no friction or air resistance to slow down a spacecraft, so even a small amount of force from a plasma engine can accelerate it to high speeds over time. But here on Earth, there's a lot of air resistance to contend with. That means we would need a lot more thrust to get a vehicle moving. And currently, plasma propulsion systems just don't provide that kind of power. Another issue is the size and weight of the power supply. Plasma propulsion systems require a lot of energy, which means a large power supply. In space, we can use solar panels to provide this energy. But on Earth, carrying around a large power supply would add a lot of weight to the vehicle, making it even harder to move. Then we have the matter of the propulsion system itself. Plasma propulsion systems operate by creating a plasma and then expelling it to create thrust. But creating a plasma requires very high temperatures. These high temperatures can be handled in space, but on Earth, they can pose a serious safety risk. And finally, there's the issue of ionizing radiation. Plasma propulsion systems work by ionizing gas, which can produce harmful radiation. In space, this isn't a big concern, but here on Earth, we need to be very careful about radiation exposure. So, while the idea of using plasma propulsion on Earth is certainly exciting, there are a lot of technical challenges that need to be overcome. But who knows? With ongoing research and advancements in technology, we might just see plasma-powered vehicles in our lifetime.
Now, wouldn't that be something?
Now that we've explored the basics, let's delve into the cutting-edge side of things, the ongoing innovations and advancements in plasma propulsion technology. One of the most exciting projects currently underway is the development of the aforementioned Vasimer engine by Ad Astra Rocket Company. Remember, this is the engine that can adjust its thrust, providing more flexibility in operation. The company is continuously working on improving the engine's efficiency and longevity. Then there's the X-3 ion thruster, a project by NASA and the University of Michigan. It's a type of Hall-effect thruster that's aiming to be more powerful and efficient than its predecessors. It's been breaking records in the lab, and we might just see it powering spacecrafts on long-duration missions in the near future. Researchers are also trying to find new and better propellants. While xenon is commonly used in ion thrusters, it's also quite rare and expensive. Alternatives like krypton, argon, and even iodine are being explored. And let's not forget about the potential terrestrial applications. Despite the challenges we discussed earlier, researchers are not giving up on the idea of plasma propulsion on Earth. And there's ongoing research into making the system smaller, lighter, and safer for potential use in our atmosphere. In fact, researchers at the Massachusetts Institute of Technology, MIT, have already successfully flown a small, unmanned plane powered by an ionic wind propulsion system, a relative of plasma propulsion. It's a small step, but a promising one. So, while plasma propulsion might seem like a technology of the future, it's very much a technology of the present. And with the pace of advancements, who knows what breakthroughs are just around the corner. It's an exciting time to be a space enthusiast, that's for sure. Now, let's talk about why plasma propulsion is such a game changer in the first place. Sure, it's cool. It's cutting edge, and it sounds like something straight out of a sci-fi movie. But there's more to it than just the cool factor. Plasma propulsion systems have considerable environmental and efficiency advantages compared to traditional propulsion methods. Firstly, let's talk efficiency. Traditional chemical rockets produce a large amount of thrust, but they are not very fuel efficient. They need to carry a lot of fuel, which adds to the weight of the spacecraft, and they burn through it pretty quickly. On the flip side, plasma propulsion systems are incredibly fuel efficient. They can operate for longer periods, and because they use so little propellant, spacecraft can carry less fuel and more payload. Moreover, the specific impulse, which is a measure of how effectively a rocket uses propellant, is much higher in plasma propulsion systems than in chemical rockets. This means they can achieve higher speeds over time, making them ideal for long-duration space missions. Now, on to the environmental benefits. The propellants used in traditional rockets can be harmful to the environment. For example, hydrazine, a common rocket fuel, is highly toxic and carcinogenic. On the other hand, plasma propulsion systems use inert gases like xenon or krypton as propellants, which are much less harmful. Plus, the small amount of propellant needed further reduces the environmental impact. And then there's the potential for using renewable energy sources. In space, plasma propulsion systems can be powered by solar panels, making them a more sustainable option for long-term space travel. So there you have it. Plasma propulsion systems are not just a cool piece of technology. They're a more efficient and environmentally friendly way to explore the cosmos. And who knows? With ongoing advancements, we might even see their benefits being harnessed here on Earth one day. Well, that would be a sight to see.